Welcome to the video that's going to be helping you out with graphing your Chapter 3 and Chapter 4 summative. So first and foremost, let's talk about your general graph requirements. So it's not listed here, but just as a reminder, you must have 10 line segments, and each line must have a different equation. You should have at least 2 vertical, 2 horizontal, 3 positive, and 3 negative sloped lines. And you must have a pair of parallel and perpendicular lines. For your parallel and perpendicular lines, they should not have a slope of 0 or undefined. And as for your color coding, you know that you should have a red line that is a negative slope, and it should be in your first quadrant, written in standard form. If it has a positive slope, it should be in quadrant 4, and it should be point slope form. If you have an undefined slope, it should be in quadrant 3, and it should be your choice in how you write it. And likewise, if you have one that's a 0 slope, it should also be in quadrant 3, and it is your choice in how you write the equation. For a perpendicular line, you can have any quadrant, and it should be slope-intercept. And for your parallel line, it should be in any quadrant in standard form. So here we have the steps to complete the summative. Basically, here's going to be our first steps. So first, you should pick the coordinates of your graph. Then, you should find the slope of the line segment. Third, you should put the coordinates in point slope form. Fourth, if needed, convert to slope-intercept form. And fifth, if needed, convert to standard form. The first step to drawing any line segment is to pick your coordinates. Before you do anything, I would look and see what you need in each quadrant first. See what you need in quadrant 1, see what you need in quadrant 2, see what you need in quadrant 3, and see what you need in quadrant 4. Then, try to make 2 coordinates that'll give you a positive, negative, undefined, or 0 slope. That's the first suggestion that I have for you when working with this step. I have my own graph right here, and I noticed that quadrant 1 needs to have a negative slope. So I picked 2 coordinates for endpoints. In this case, I chose 2, 3, and 0, 5. I graphed those coordinates by putting dots on them, and then I drew a line in between them to complete my line segment. So once again, your first step, just look and see what you need off that original rubric, and then try to match it up and just pick your own coordinates. Whatever makes you happy, go for it. The next step that you will always use in this process is finding the slope. So, just a kind reminder, the slope formula is m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So all I have to do is take the coordinates that I chose for my first step and write them down. So here I've got 2, 3, and 0, 5. So in this example, I'm going to label them as x sub 1, y sub 1, x sub 2, y sub 2. And from here, you just have to substitute it into your equation. So, m, or my slope, equals 5 minus 3 divided by 0 minus 2. Simplifying the top, we get 2 divided by negative 2. And in this case, that equals negative 1. So your slope will be negative 1. The next step in this process is to enter your coordinates into the point slope form. Now that you have a slope and coordinates, you can officially use the point slope form. So here, I'm just going to remind you that I have the coordinates 2, 3, and 0, 5. And we found out that my slope is negative 1 in our last segment. So all you have to know is our formula, which is y minus y sub 1 equals m times x minus x sub 1. So it doesn't matter which one I substitute in here, but for the sake of just continuing on with my typical substitution, I'm going to use my first set of coordinates for this example. Again, you can use either set of coordinates and it will work out every time. So to substitute that in, I have y minus 3 equals negative 1 times x minus 2. And that's really all you need for this form. Pretty simple. So you should be progressing on to this step if you're looking at an equation that does not require point-slope form. If your equation did need to have point-slope form, you can finish at the previous segment and you're all set. But if you have to convert it to slope-intercept form, or if you have to convert it to standard form, this is the next step to complete that. So first, let me remind you of the equation that we had last. From our last segment, we found out that in point-slope form, our equation was y minus 3 equals negative 1 x minus 2. Pretty simple. So now we want to get it into slope-intercept form. And as a reminder, slope-intercept form is y equals mx plus b. So when you think about it, it's really just like solving an equation for y. So that's exactly what we're going to do here. To first solve this for y, we're going to distribute this negative 1 to both of the terms inside of our parentheses. After this step, we're left with y minus 3 equals negative x plus 2. Then all we have to do is get y by itself. So the next step is to add 3 to both sides. That gives us y equals negative x plus 5. So if you have to have an equation that has slope-intercept form, this would be your final equation. If not, we're going to keep moving on and I'll show you how to get to standard form in the next segment. So if you've made it this far, you probably need to have your equation in standard form. For example, if you have a negative slope, we ask that you write it in standard form. So, as always, you first started by putting it into point-slope form, then you converted it into slope-intercept form, and now I'm going to show you how to take slope-intercept form and convert it into standard form. From our previous segment, we found out that our equation is y equals negative x plus 5. And we want it to look something like ax plus by equals c. And remember, a, b, and c must be integers. And what that means is that they can't be fractions. So no fractions. That's a biggie. We'll go over what it means if you have one that is a fraction next. But for now, with this example, we want to get our x term and our y term on the same side. So I'm going to add x, use inverse operations, to get these two onto the same side. And just like that, I find my equation is x plus y equals 5. This one was pretty simple, and that's really how it would work for a number that has an integer. As we can see, our coefficients would be 1 and 1, and all three of these numbers are integers. There's no fractions or decimals anywhere. So now you're probably wondering, well, what happens if I do have something that winds up being a fraction? Alright, so if you've made it this far, I'm guessing that you've probably had some sort of issue where you realized, wait a minute, what if I have a fraction in my slope-intercept form? A fraction is not the same thing as the integer that's required. So this is just going to show you really how to handle that situation. So if you have an equation like y equals 1/2 x plus 6 where there is a fraction, we're going to still treat it the same way at first. We're going to try to get our y and our x on the same side of the equal sign. So I'm going to subtract 1/2 x from both sides. And from there we have negative 1/2 x plus y equals 6. So the only thing you have to do here to make it work and fit the integer rule is we can multiply every single term by 2, or by the denominator. So we're going to multiply that by 2 as well, and we're also going to multiply this by 2. So if I multiply negative 1/2 x by 2, I'm left with negative x. Then y times 2 gives me plus 2y, and 6 times 2 gives me 12. And here, we're happy once again because every single one of our coefficients is in fact an integer. We've got negative 1, 2, and 12. Hopefully that helps. If you guys have any questions, please let me know, and thank you very much for watching.